Similar triangles are two triangles that have the exact same angle measurements, and because of this, their sides are going to be proportional to each other. They could be equal to each other if they have the same side measurements, but typically we're going to look at things that are being either scaled up or scaled down. And that's what we can see here. We have a 90-degree angle, and then these marks here means that these two angles are the same, and these two angles are the same. So like, for instance, this could be like 40 degrees, that'd be 40 degrees. This could be then 50 degrees, and that'd be 50 degrees. If this is the case, if we have the same angles, that means the side measures are just going to be scaled, and you can use a proportion to show that. So I could write this one to this side, so x over 15 is the same thing, right? This side is the same as this side, because you can see that we have this angle and the 90 degrees, this angle and the 90 degrees. So this side and this side are proportional to each other. It's the same side that we're talking about. And this side and this side are the same side, as well as I could use y1 and y2. Those two sides would be proportional to each other. They're just a scaled version. So I can create the proportion x over 15 equals the same side on top, same side on bottom, 5 over 3 that we're referencing there. I could also do x to 5 and 15 to 3. X to 5, 15 to 3. Either way I do it, if you solve this thing using cross multiplication, I'm going to get 3x equals 75, then divide by 3, x equals 25. Here I get 3x equals 75. Same thing, divide by 3, x equals 25. 3 times 5 is 15. 5 times 5 is 25. So that's the proportionality. It's being scaled up by a factor of 5. Now, suppose these two triangles are similar. What proportions can be written to find x? So if I'm looking at these, right, I see 9, 12x, 3, 4, 5. It also looks like this angle here references this angle. This angle here references this angle. And this one here is this angle. Okay, so what proportions can I write? Well, I can write 3 goes to 9. And I have to have x in there, so I need to reference this side. So I have to reference this side as well. So if 3 is on this triangle, that means 5 is going to be on the same side as the proportion, 3 on top and 5 on top. And 5 goes to x. So if 3 goes to 9, 5 goes to x. Or I could write if 4 goes to 12, 5 goes to x. That's also a valid proportion. I could also write 9 over x equals 9 over x is 3 over 5. I could write 12 over x. 12 over x is 4 over 5. And you can kind of see that these two things are really the same proportion. So are these two. If I cross multiply, I get 3x, 3x, 9 times 5, 9 times 5. It gives me the same exact equation to solve. Same thing here, 4x, 12 times 5, 4x, 12 times 5. And I can, of course, flip these if I wanted to. Those will also be valid proportions. So I could have 9 over 3 equals x over 5. There's so many proportions that you can get from this. In this case, right, the whole thing we're doing here is we're doing 3 times 3, 4 times 3, so 5 times 3. It's going to be 15 is what x equals. And no matter what proportion you solve, as long as you set up correctly, you will get the solution x equals 15. All right, let's see this in practice and actually solve for some unknowns. So here I have these two triangles. It's important to note which angles reference which angles. This angle is going to reference this angle. And the way it looks is that this side, or this angle, and then this angle here, and this angle here. X here references 8.6. And then 23.5 is the same thing as the same side as 7.3. And of course, y and 52.3 are related to each other. So we can now do, we can create a lot of different proportions for this. I need to use these two sides because these are the sides that I know. 7.3 times what is 23.5. That's the scaling that we're going to use. And then I can use this one to find x, and I can use these two to find y. So my first proportion I'm going to get is 7.3 goes to 23.5. And then 8.6 goes to x, right? 7.3, 8.6 on the top, 23.5, and x is on the bottom. I can solve this. Let's see, 8.6 times 23.5. I get 202.1. Now I just need to divide by 7.3. And I get approximately 27.68. I should probably round it to one place since they all have one there. So 27.6 or 27.7 is my side length there. Now to solve for y, I'm not going to use the one value that I just had because I rounded this one. I'm going to instead use the numbers that I have been given to solve it. So I'm still going to set the same kind of way. 7.3 over 23.5 equals 7.3, and y are on the same triangle, and y is the same thing as 52.3. Okay, cross multiply and divide again. I get 23.5y. 7.3 times 52.3 gives me 381.79. I just need to divide by 23.5 on both sides. And I get 16.2 if I round to two places. Okay, this next triangle is a little bit weird because we actually have two overlaid triangles. I can actually take this inner triangle here and separate it if I wanted to get x and 12. And what this does is it tells me that this angle and this angle are the same. This angle here and this angle here are the same. And this angle here and this angle here are the same. So this bigger triangle has, it says, this is 6 and this is 12, which means that this full size here is 18. And this side here is 32. So 18 and 12 are related, and 32 and x are related. So just important to realize what we're talking about. The triangles could be overlaid like this, but it's still just two triangles that are similar. Okay, to find x, once again, all we have to do is set up a proportion. It's important to note that you're looking at this full length here, not the 12 and not the 6. You have to add them up to get this 18. So let me do 18 goes to 12 and 32 goes to x. Again, 18 and 32 are the same triangle, so they're on both on the top, and 12 and x are on the same triangle, so they're on bottom. I can cross multiply and divide now. 18x equals 32 times 12 is 384. Divide by 18 and I get x equal to approximately 21.3. It's actually 21.3 repeating, so 21 and a third. That is the scaled side length. Okay, Sandy wants to know the height of a flagpole. First, she knows that she is 4 feet 8 inches tall. And at a specific time of day, she measures her shadow, which is 5 feet long. The flagpole's shadow is 15 feet long. So first off, what are the similar triangles can be found, and what is the height of the flagpole? So she is, this is Sandy here. I'm just gonna draw like a side length, is 4 feet 8 inches, and her shadow is 5 feet. I can create a triangle like this because she's standing straight up, and the shadow is 90 degrees angle on the ground from her. I can also draw the flagpole. The flagpole is not going to be perfectly to scale, but the flagpole is 15 feet long, and the shadow of the flagpole is 15 feet long. And we're asking, what is the height of the flagpole? Now, the reason why these two triangles are similar is, first off, we know there's a 90-degree angle there. And because the sun, right, the sun is way, way up in the sky, and it's shining the light rays down that creates the shadow. Because the sun is so far away, we can say that the sun hits both the top of the flagpole and the top of Sandy's head at exactly the same angle, which means this angle and this angle are the same. It's because the sun is so far away that you can assume that's true. And if the 90-degree angle is the same and this angle is the same, this angle by default has to be the same. All three angles have to equal 180 degrees when you add them up. And so that angle must be the same for both triangles. So they are indeed similar triangles. And now I can find x by doing the proportion. I need to write this as just feet. Everything here is written in feet. This is written in feet and inches. There are 12 inches to a foot. So 8 over 12 is going to be 2/3 of a foot. So really this is the same thing as 4 2/3 feet. Okay, the proportion we get is going to be 4 2/3 over 5. So this, and then x over 15. So 4 2/3 and x are the same referenced side, and 5 and 15 are the same reference side. You can actually kind of see here, all we're doing here is just timesing by 3 to get to 15. So we just need to times by 3 here to get to x. We can also just solve the proportion. Either way you want to do it. I'm just going to multiply by 3 though. That's going to be easier to do. So I'm going to do 4 times 3 plus 2/3 times 3. Going to equal 12 plus, this is 3 over 1. Those cancel, plus 2. And we get 14 feet. So the flagpole is 14 feet tall. Now, a support brace needs to be added to this metal triangle that's shown here in this diagram. This is the brace here. And it is parallel to this side here. So it goes exactly the same direction as this side. And it divides this side piece into 2.5 meters and 3.75 meters. What is the length of the brace that is required for this setup? Well, first off, we know this angle is similar to itself. And this smaller triangle here really is just this triangle here. This angle and this angle are the same. And then this angle here and this angle are the same. It's exactly the same kind of idea as this overlaid triangles here. So everything's similar. This is x, this is 2.5, and this distance here, right? We're talking about this full distance here. That's going to relate to the 2.5. X and 11.25 are related to each other. But this full distance here is going to be 2.5 plus 3.75, or 6.25 meters. So we can now create the proportion. Right, 6.25 and 2.5 are related. And then 11.25 and x are related. So here's a sample, one way you can set up the proportion to solve it. Cross multiply and divide, 6.25x equals, I get 11.25 times 2.5 is 28.125. Now I just need to divide by 6.25. And x equals, I'm getting 4.5, and the unit of measure here is meters.